Hey everyone, we live in this amazing age of AI, automation, and getting anything we want almost instantly. So you'd think that actually making things, physical stuff, would be getting easier by the second. But what if I told you the exact opposite is happening? And that's the big question we're tackling today. It's this wild paradox. The smarter our technology gets, the more our manufacturing systems are struggling with challenges that are almost mind-bogglingly complex. It's a huge task, and we're going to break down exactly why. So a big piece of the puzzle is us. It's what we, the customers, expect versus what factories can actually do. We want endless choice, products made just for us, perfect quality, and we want it all delivered yesterday. But on the factory floor, they're dealing with exploding complexity and something called bottleneck drift. That's when the main holdup in the production line just randomly moves from one machine to another, wrecking any plants. It's a nightmare of uncertainty. Let's dig into the first big problem area. All right, first up, the data problem. And believe me, it's a big one. Modern factories are just drowning in data from sensors, from supply chains, from everywhere. The dream is to use all that info to see the future, to make perfect plans. But yeah, that's where things get really, really tricky. Okay, so to even try to manage all this, engineers use these super sophisticated tools, one of which is called a Markovian model. Now just think of it like a crazy detailed map of everything that could possibly happen in a factory. I mean, every single machine state, every possible product flaw, every little thing, and the probability of it happening. It sounds like the perfect solution, right? Well, here's the catch. Real life is, well, it's messy. Even a production line that looks simple on the surface has a bazillion moving parts. And when you try to map every single one of those possibilities, you get a combinatorial explosion. That's a fancy way of saying the number of possibilities just goes ballistic. It doesn't just add up, it multiplies, and it multiplies fast. Every new product option, every potential delay, just makes the problem grow exponentially. It's absolutely insane. And that, right there, is the state explosion problem. And seriously, this isn't an exaggeration. For a lot of these systems, the number of possible outcomes is bigger than the number of atoms in the known universe. I mean, how do you even begin to analyze that? You can't. It makes perfect prediction pretty much a fantasy. And the puzzle just gets deeper. Trying to predict timing? Forget it. Demand changes constantly. People's skills vary. The data from your fancy sensors, a lot of it's not even that accurate. That bottleneck we talked about, it moves around, making your well-laid plans totally useless. Heck, it's even tough to prove if that shiny new robot you bought is actually helping the bottom line. It's just this tangled mess of data problems. So all of this data chaos creates a very real, very physical problem. It's one thing to struggle with predictions, but it's another thing entirely to try and adapt the actual factory floor to a world that just won't sit still. Look, the old way of doing things is dead. You know, the Henry Ford model of making 1 million identical black cars for years? That's over. We want stuff made just for us, and we get bored easily, so we want new models constantly. That means the factories themselves have to be able to pivot on a dime. But trying to build one of these super flexible, reconfigurable factories, oh man, it's a huge uphill battle. And it's not just about the technology. You're fighting the budget, you're fighting a company culture of this is how we've always done it. And honestly, a lot of the time, people just don't know how to build for change, especially if you're trying to upgrade a factory that's been around for decades. And this quote just nails it. You read the research, and everyone agrees this is the future. It's all about reconfigurability. But then you look at actual factories, and yeah, it's just not happening. The source material is pretty clear. Very few companies have really cracked this code in a big way. It's because that old top-down model with one central brain trying to run the whole show is just too clunky. It's too slow. It breaks easily. It just can't keep up with all the chaos. Supply chains going crazy, customers wanting 1 million different things, and workflows that are totally random. The whole system needs a new brain. Okay, so we've talked data, we've talked machines, but the final, and maybe the biggest hurdle, it's us. It's the people. The way we design and run these places is, frankly, a huge part of the problem. I mean, think about it. Who designs these incredibly complicated factories? It's usually a small handful of experts. And as brilliant as they are, they're still human. They make mistakes, they have their own biases, they have blind spots. And this is where it gets really bad. When one of these experts makes a huge design decision, why did they do it? What were the other options they considered? What were the trade-offs? So often, none of that gets written down. It's all just stuck in their head. So what happens? A successful factory design becomes like a magic trick. The magician knows how it's done, but nobody else does. You can't copy it, you can't learn from it, you can't improve on it. And that raises a massive question. How is an entire industry supposed to get better if its own greatest successes are a complete mystery? And these human challenges pop up all over the place. The biggest safety risk might be at one single workstation. You've got different teams, like planning and scheduling, not talking to each other, creating plans that just don't work together. And of course, you've always got that classic tug of war. Do we make it perfect, or do we make it fast? Okay, so we've got this mountain of challenges, right? Exploding data, factories that can't change, and all the quirks of us humans. So what does it all mean? Where do we possibly go from here? Well, one thing's for sure. There's no easy fix, no magic bullet. The only way forward is to attack all three of these problems at the same time. You have to solve the data problem and learn to pull real insights out of all that noise. You have to solve the adaptability problem and build factories that can actually evolve. And you absolutely have to solve the human problem. We need to turn that magic trick into a science that anyone can learn and repeat. And that leaves us with one final massive question. Because let's be honest, we're not going to stop wanting cooler, more personal, more complex stuff. So the real test is, can the systems that build our world actually innovate fast enough to keep up with our own imaginations? Something to think about. Thanks for joining me.